Hello and welcome to this R tutorial. In the following tutorials, we will be implementing multiple linear regression in R, and right now, as usual, we are going to start with the basics, which is to set our folder as working directory. So right now, I'm on my desktop. I'm going to my machine learning AZ folder, then part 2 regression, and then we want to go to multiple linear regression, and here is the folder. Make sure that you have the 50 startups.csv file, and if that's the case, you're ready to click on this More button here to set the folder as working directory. All right, now let's start with step 1, which is to prepare the data to make our multiple linear regression ready to be built. So as usual, we're going to use our template, the data preprocessing template that we made in part 1, and we're just going to copy this, copy, and paste it here. All right. And now let's take care of the few things to change. So first we will change the name of the dataset, which is here 50 startups. All right, 50 startups.csv. We can select this and execute to have a look at our dataset. Here it is, and that's the dataset. I'll remind what this dataset is about. So this contains informations of startups, actually 50 startups, and these informations are some amount of money spent. So for example, there's the amount spent in R&D, administration, marketing, and finally there is also the state in which the startup operates. And finally, we have a last column here, which is the profit, and that's the profit we want to predict with our multiple linear regression models. And we want to predict that profit based on this independent variables, which are the R&D spend, the administration, marketing spend, and the state. So we are doing this because we are doing a mission for investors who want to know in which startup they should invest their money. And so not only they want to predict the future profits for new startups based on the same informations, but also they want to see which independent variable has the highest effect on the profit and which one governs the relationship between the profit and those independent variables. Is there an independent variable that has a highest effect than another one? Does the state in which the startup operates have an impact on the profit? We'll find that out thanks to our multiple linear regression model in R. And thanks to this model, the investors will be able to draw some insights from our results. Okay, so now the next sub-step of the first step data preprocessing is to split the data set into the training set and the test set. But is it the sub-step we need to do right now? I know that the template is suggesting that, but let's not forget that in our data set we have one specific variable which should strike our attention. Well, it's this one, it's the state variable, because it contains categories, which means it's a categorical variable. And remember, when we have a categorical variable like this with categories written in text, this would cause some issues in our machine learning model equations. Because how do you want to make a linear equation with one of the variable written as text? It wouldn't make any sense. So what we're going to do, of course, is to encode the state variable. And to do this, we are going to use what we learned in part 1 data preprocessing, only we didn't include that in the template because this will actually be one of the only examples where we'll need to encode our categorical data. We put it in a separate file, and so right now we're going to open this separate file. So I'm going to jump back to my folder part 1 data preprocessing, which is here. And here we go. So the categorical data R file is here. So let's open it. Here it is. And right now what I'm going to do is I'm going to take this, copy, and paste that here. Okay. Then of course we need to change a few things here. So we need to change the name of our categorical variable. So in part 1 it was country, and here it is state. Okay. Same here. We need to change country by state. Let's not forget to align this. This is very important in R and in any programmation language. Here we go. There. And now we need to change the levels. So before, the categorical variable was the countries, and the 3 categories were France, Spain, and Germany. And here our 3 categories are New York, California, and Florida. So let's do it on our data set. Actually, I will close that because we no longer need it. So here our levels are, we said New York, California, and Florida. Okay, and then the labels, that is the numeric numbers, which are actually factors, the numeric factors that are going to replace these three texts here, New York, California, and Florida, are these numbers you choose here for labels. So here we have 1, 2, 3. That means that New York is going to be 1, California is going to be 2, and Florida is going to be 3. You're going to see, I'm going to select this and execute. All right, and now let's look at our data set. As you can see, the state is now encoded with the 1, 2, 3 values. So 1 for New York, 2 for California, and 3 for Florida. Let's go back. Okay, so the encoding is done, and that's a much better thing for our model. Now, our model has a greater chance to work. And now the last thing we need to do is to split the data set into the training set and the test set. So here, let's not forget to change the name of the dependent variable here, which is not purchased, but profit. All right. And then we need to change a split ratio if necessary. Let's see, we have 50 observations. So a good split would be to have 40 observations in the training set and 10 observations in the test set. So that makes actually an 80% split ratio, 80% going to the training set. And this is already what we have. Perfect. So we don't have to do anything here for the split ratio. And we are ready to take all of these and execute. And here we go. Let's have a look at our training set and our test set. Here it is. That's the training set. Okay, so it contains 40 entries, 40 observations. Great. We have our encoded variable for state. That's perfect. And then a test set that contains 10 observations and everything looks fine. All right, so let's go back to multiple linear regression. And the last step is feature scaling, but as for simple linear regression, we won't need to apply feature scaling manually. This will be taken care of with the function that we're going to use to fit multiple linear regression to our training set. So we're all fine, we're all good here. We are ready to move on to the next step. We're ready to fit multiple linear regression to the training set. So as for simple linear regression, the first thing that we're going to do is to introduce the multiple linear regressor, and we're going to call it regressor. And then as for simple linear regression, we're going to use the LM function, here LM, and in parentheses, we're going to input the parameters. Okay, so let's have a look at the LM function here by pressing F1. Here we go, fitting linear models. Let's look at our arguments. So that's the same as for simple linear regression actually. The first argument is formula, but this time you're going to see how we will need to change the formula syntax. And then the second compulsory argument to input is the data. And of course, it's going to be the training set. So let's first input the formula. So formula here. So remember in simple linear regression, we wrote the formula salary proportional to years experience. And here it's almost going to be the same. But the difference is that we have several independent variables. We have 4 independent variables. In simple linear regression, the dependent variable was proportional to the only independent variable. Well, here it's going to be the same. The profit is going to be proportional to these independent variables. Only the correct way to say it is not proportional, but is the profit is going to be a linear combination of the independent variables. And formula equals profit alt n. And here the idea is to add all the independent variables separated with a plus sign. So let's look at them. It's R, D, spend. I'm using the dot here because in the dataset we have some spaces and R replaced them by dots. So here it's dot, then plus, and then the other variable, which is administration, plus marketing spend, plus state, and that's all. So that's how you express the profit as a linear combination of all these independent variables. However, there is a trick to write this formula in a much more efficient way. It's instead of writing all the independent variables here, we can simply write a dot. That's what we can simply write, and that's the exact same equation. R understands that you want to express the profit as a linear combination of all the independent variables. So the dot here just means all the independent variables. Okay, so that's for the first argument, formula equals profit as a linear combination of all the independent variables. And the second argument is data, and as we said, it is, of course, the training set, because we want to train our multiple linear regression model on the training set and then test the performance on the test set later. All right, so that's it for building our multiple linear regression regressor. So we're going to select this and execute. Here we go. And now there is something very important to do. And this is something very practical, very useful in R. It's that we are going to look at the informations of our regressor that we just built here. And to do this, it's really simple. We just need to, it's actually like simple linear regression, only here this time it's going to be more interesting because we will have several independent variables and some of them will have a stronger effect on the dependent variable. So we'll see, it's going to be more interesting. And so like in simple linear regression, we're going to write summary of our regressor. All right, and just press enter. And that's it. I'm just going to move that up. And here we have all the info of our regressor. Okay, so here the first thing is just a reminder of what the formula is. So the profit is expressed as a linear combination of all the independent variables, and our regressor is trained on the training set. Okay, perfect. Residuals, we will be talking about that at the end of this part. So let's not focus on that right now. However, that's the important part, the coefficients here. That's what we need to focus on right now. Because as you can see, it gives some info for each of your independent variable. Oh, by the way, state 2 and state 3 here are the dummy variables. And that's because, you know, I told you that the library takes care of everything for you. Not only it created the dummy variables, R knew that it had to create dummy variables for the state variable. And we helped R to understand that because we encoded the state variable as factors. So R did all the job for you because not only he created the dummy variables for the state variable, but also R didn't fall into the dummy variable trap because as you can see, it automatically removed one of the dummy variable to avoid some redundant dependency. So that's perfect. That's the beauty of R libraries as well as Python libraries. In Python, I know we specified a new section to remove the dummy variable, but that was just to remind you about the trap. We don't need to do it. R and Python take care of that for you. So that's great. That's the first thing to notice. And then what I was telling you is that for each of the coefficient, we have different information. We have actually the coefficient in the linear regression equation. Then we have the standard error, then the t-value, then the p-value here, and then the significance level. So the most important info by looking at this are the last two columns, the p-value and the significance level, because these columns tell us about the statistical significance of the independent variable onto the dependent variable. That means it tells us if each of the independent variable has a significant impact on the dependent variable. Okay, so let me first explain what the p-value is. The most important thing to understand is that the lower the p-value is and the most statistically significant your independent variable is going to be. That means that the lower the p-value is, the more impact or effect your independent variable is going to have on the dependent variable. And generally a good threshold to use is the 5% threshold. That means that if your p-value is lower than 5%, then that means that your independent variable would be highly statistically significant, and the more it is above 5%, the less it will be statistically significant. So that's how you must interpret the p-value. And then we have this last column, which is just a faster way of interpreting the coefficients. Because as you can see, we have this line here that explains us about the stars. And basically what the stars mean is that when the p-value is between 0 and 0.1%, then there's going to be 3 stars, which means a highly statistical significance of your independent variable. If the p-value is between 0.1% and 1%, then it's a quite high level of statistical significance. Then if your p-value is between 1% and 5%, then the independent variable is still statistically significant, but will have a less strong effect than the first categories. And then if your p-value is between 5% and 10%, it's borderline. The independent variable might have a certain level of statistical significance, but not that much. Anyway, a lot less than those independent variables that have 3 stars or 2 stars. And then if your p-value is between 10% and 1, then there is absolutely no statistical significance. That means that your independent variable won't have any effect on the dependent variable. So that's very interesting because when we look at our independent variables here, we notice that only one variable has a high statistical significance onto the dependent variable. It's the R&D spend. So it looks like the profit is mainly governed by the R&D spend. That means that it's the R&D spend that has the only strong effect on the profit. So that's a very important information for our investors because they now know that they shouldn't only be looking at the profit itself by, just looking at the maximum profit to decide where to invest, but also it should be looking at the R&D spend variable. It should be looking at the amount spent in R&D to add another criterion in their investment decisions. So that's a very good info. And basically what it means, what all this means is that among all the independent variables here, the only predictor, the only strong predictor of the profit is the R&D spend. The rest is absolutely unuseful. So actually what this means is that we could rewrite this multiple linear regression equation and turn it into a simple linear regression, because since the only independent variable that has an effect on the profit dependent variable is the R&D spend, then the formula could be profit equals R.D.spend. And that would be okay. That would actually give us the same prediction. And now what we only have to do left is to predict the test set results. As for a simple linear regression, it will be very quick. We will just need one line for this, and it's going to be ypred. I'm introducing the vector of predictions here, ypred. And then I'm going to use the predict function. And in the predict function, I will just use 2 arguments. One is the regressor. You have to specify with which regressor you want to predict your test set results. And of course, it's with our multiple linear regression regressor that we define here. And the second argument is new data, which is the set of the new observations you want to predict the result. You want to predict the profit. And so, of course, this new data is going to be the test set. Don't worry if so far we're only making predictions about the test set. You will see that in the next sections, we'll be making predictions of new observations, which won't be the test set observations, but some single observations. You will understand why we will do this, and you will see that the purpose of doing that is actually going to be pretty fun. So so that's ready. The predict function is ready. It has its 2 arguments, the regressor and the new data. So we're ready to select this and execute. All right. And now our ypred vector of predicted results of the test set is ready. So what I'm going to do now is to type ypred in the console to have a look at it. Here it is. So as you can see, this contains 10 predicted results. These are the 10 predicted profits of the 10 observations of the test set. So for example, let's compare the real profit and the predicted profit. So let's look at our test set here. Okay, so let's look at our startups. Let's look at startup number 4. So startup number 4 has a $182,000 profit. And what about the prediction? $173,000 profit. So that's the predicted profit, which is not far from the real profit, so that's pretty good. Okay, what about the second one? $166,000 for the real profit and $172,000 for the predicted profit. Not too bad either. Then third observation, 155, 160, good. 146, 135, not too bad. Then for example, let's look at the startup number 24. Startup number 24 had a real profit of $108,000 and our predicted profit is $110,000. So here we're pretty close. That's an accurate prediction, a good one. Okay, and that's even better for the last 2 ones, because here it's 99,000, here it's almost 99,000, and 97 here for the last one, and almost 97. So that's pretty good. That's a good model. And remember, that's the model with all the independent variables. But as we saw, there is only truly significant variable, which was the R&D spend. And so if we try to recompute the regressor by only putting the R&D spend independent variable here, you will see that the predictions are going to be the same with the same accuracy, because the R&D spend is the only strong predictor of the profit. So you can try that yourself. It could be a good practice. You can play around with the different independent variables. So I will let you do it yourself and continue to analyze, interpret, and play around with the multiple linear regression. That's the end of this tutorial. I was very happy to teach you how to make a multiple linear regression model. I look forward to seeing you in the next section, where we'll be talking about a new kind of regressor, because this time you're going to see that it's not a linear regressor. It's going to be a polynomial regressor, and I can't wait to show you how it can give powerful predictions, and we're going to use it on a very funny example. So there will be quite a challenge here, and just to give you a teasing of what we're going to do, we're going to make kind of a lying detector. So I look forward to seeing you in the next section, and until then, enjoy machine learning.